Good morning. Today we are correcting PO55. PO55 is a PO. It is one that's a power objective. We have to understand this one. I can solve an unknown angle in a triangle or a quadrilateral. Two things that we have to remember for this is triangles, all the angles equal to 180 degrees. Quadrilateral has 4 sides. All the angles will always equal to 360 degrees. Because like I showed us, a quadrilateral are 2 triangles put together to make that 4-sided figure. So 180 for the triangle, 360 for the quadrilateral. The first 2 we did together. The bottom 2 you were working out. So our missing angle here would be 17 degrees. Here would be 35 degrees. Because if we add them all up, that gets us 100 or 360 degrees. Remembering that the little square means it's a right angle and it is 90 degrees. So for this objective, we are using previous knowledge from other objectives. So knowing a right angle is 90 degrees, knowing supplementary angles that we need to know to answer this. I want to really point out where our angle measurements go. There were a lot of us when I was walking around that put 60s here at our little hash marks. Those hash marks are on a side. That is telling us the side length. That was not the question. The question was missing angles. I don't want to know how much a side is. I don't want to know their length. I want to know my angles. So angles always have the degree and they always go into that corner. So when you're doing angles, remember it's the corners that we put them in, not as those side lengths. Does that make sense? We know that if all the sides are equal, it's equilateral. If it's an equilateral triangle, it has to be an equiangular triangle. So all 3 angles are equal. They have to be 60 degrees. 60 plus 60 plus 60 is 180. So equilateral, equiangular will always be 60-degree angles. For this one, we talked about how these 2 angles are the same. So we added 100 plus 100 was 200. 360 minus 200 was 160. We divide it by 2, and they are 2 equal angles at 80 degrees. Down here, we had to know that 140 is supplementary to what inside angle. So 180 minus that 140 gave us 40 degrees on this side. You had to list it because we needed all missing angles. So you had to put the 40 degrees for this angle. 75 plus 40, we subtract that from the 180 and we get 65 degrees for our other angle. So you had to list both angles. On the test, you have to fill in all missing angles. For this one, we had 2 supplementary angles that we needed to figure out. So 180 minus 105 gave us 75 degrees here. 180 minus 130 gave us 50 degrees here. And then we add those 2 together, subtract it from the 180, and we get 55 up top. So you had to have all 3 inside angles filled in. So that was 55, 50, and 75. Any questions on those ones?
I just got a computer wrong.
Do you understand how you should have solved it?
No.
So what was it that you did so I can see where you were thinking? What numbers did you put?
I put. I don't even know. I was looking at these ones, but then I realized I didn't really know what I was doing.
Okay. So what you were doing was you were adding the outside angles and subtracting those. You forgot that with a triangle, we worry about the inside angles. So I see what you were doing. You were worried about outside angles and those being 180. But those are obtuse. They are way too big. So you would have, if you would have done your math correctly, you would have gotten a negative number. So what we have to do is we want, when we're talking about missing angles of a triangle, because this will be on the test, so I want you to understand, we want always the inside of our shape. Quadrilateral triangles, we're always looking at the inside missing angles. So you have to look at it and say, oof, there are 3 missing angles. How do I solve that? Using our previous knowledge for supplementary, for the right angles, for if it's an equal angular. So you have to use that previous knowledge to be able to say, oh, this is supplementary angle. I know one angle is 130, the other angle has to be 50 because it has to equal 180. Same thing on this side, 180 minus that 105. So now I have 2 inside angles. Now it's easy to find that third angle. So always look inside the shape. Use the outside information to help you fill in the inside of the shape. Does that make more sense?
Yeah.
Sorry.
Oh, what if you put the 75 in like a round spot? Would it still be like?
So if you put 75 up here,
Yeah, would it be rounded?
well, because then you would put 55 down here, and 55 plus 105 does not equal 180. So you are correct, that would be wrong, because these two have to equal 180. So yes, the placement of your angles matter, very much so. The only one that doesn't matter is this one, because they're all 60 degrees. Good questions. Any other questions? If it is, yeah, no, it's always gonna matter, the placement of the angles, unless they're all the exact same angles. All right, let's look at our review. As I was walking around, I noticed there were people not putting degrees and numbers on their shapes and their angles. On the test, it does matter. You can't just, I saw somebody who did this for a complementary angle. That's not telling me that you understand that complementary, they equal 90 degrees. You have to put in measurements that would show me they equal 90 degrees. Okay, you have to put those in so I know that you understand completely. For the isosceles triangle, I don't have any numbers, but I have those 2 lines. What do those 2 lines tell me? Madeline? That they're equal size. You could put in a size for them. I don't know why it's not wanting to work. So I could put in a 5 and a 5, and it's showing that they're equal. Or you could put the hash lines showing they're equal. Because the actual size, the actual measurement isn't what matters. It's knowing that they are equal. So you put in 2 numbers that are equal, or you put the hash lines showing that they are equal. Does that make sense? This one for vertical angles. You have to draw the X. You have to have the opposite angles being identical. So vertical angles mean we have the X showing that they share the vertex. And I have 110 and 110, 70 and 70. Why did I pick those numbers? Why would I pick 110 and 70? Kelly? Because they equal 180 when I add them together. So you have to look at your 2 numbers. If you add them together, do they equal 180 degrees? Because on the test, if you put 45, 45, 65, and 65, would that be correct? they are opposite angles are equal, would I accept that as an answer? Yes or no? You don't know?
Oh, I don't know.
Okay. I want you to decide yes or no. Thinking about what I just talked about with the angle measurements I put and why I picked those angle measurements. Why did Callie say I picked 70 and 110? Hannah Mae?
It has to equal 180.
They have to equal 180. This is a straight line. These two angles have to equal 180. Does 65 and 45, if I add them together, does it equal 180? No, it doesn't. It equals 110. So this would be wrong on the test. Okay? You have to make sure that you're showing all your knowledge. If you are drawing vertical angles, you have to make sure that the supplementary ones equal 180. So you're not only noticing that opposite angles are equal, but that they equal 180 because they are supplementary. That makes sense. Thumbs up, thumbs down. Do you understand the vertical angles? We're getting there? Okay. Corresponding angles. Corresponding angles, you have to have your two parallel lines. One line cutting through them. So we have a set of vertical angles here, and it's identical to the vertical angles up here. So corresponding angles, same position, same degree. So right here is 110, up here is 110 degrees. Again, like with those vertical angles, they have to equal, supplementary have to equal 180 degrees. It matters. So on the test, if they are supplementary angles, you must have them equal 180. If they are across from each other, opposite, they have to be identical. Corresponding, you take one set of degrees and it's actually the exact same thing up on the second set. Questions on corresponding angles? Show me your thumbs. How are you feeling about corresponding angles? Oh, well, a lot more feeling better. Still a few shaky. So the vertical and the corresponding are the ones that kind of giving us a little, I really need to think about it. It does take thought because we have to remember the supplementary straight line, those two angles equal 180. Okay, we're going to keep going through this and we'll go through it when we review before the test. The more we talk about it, the more we actually pay attention to these review problems, the easier and it will come for us. Scalene triangle. Did it matter what numbers I put on the sides? Because remember, scalene is sides, so I don't want to see angle measurements. The only thing that matters is that they're all different numbers. They don't have to equal anything because it's side measurements. I don't want to see angles. I want to see that sides have different measurements. That's what I'll be looking for on the test. A right angle, you could have put the little box, you could have put 90 degrees. It has to look like a right angle. You can't draw that and call that 90 degrees. It has to look like it's that right angle. Either the box or the 90 degrees tells me you know it's right. An acute triangle. An acute triangle, what's the important thing that we have to show? Amanda? Yeah. We have to show our angles that are smaller than 90 degrees. Here we're showing, we know what 90 degrees looks like. all of these angles are smaller. I didn't fill in the angles. You definitely could to really show that you understand it. You could call it 20 degrees, 50 degrees. Nope, that won't work. Why wouldn't that work? Because I need to equal 180 degrees. So if I did 20 and 50, then my other angle would have to be 110. So I might call this one 60 degrees, so then this one would be 70 degrees. So again, showing that all three angles are less than 90 degrees, and when we add them up together, it equals 180. It has to equal 180 degrees. They all have to be under 90 degrees. Okay, so every triangle always, I want you to hear this. Every triangle always equals 180 degrees when we add the three angles up. If it's acute, they all have to be under 90 degrees. You can't have super tiny, because then we're going to need a big obtuse angle. And we can't have that if it's acute. Supplementary angles, you had to show your degree measurements to show that you know that they equal 180 degrees. As you can see, I like to stick with what I know. I know 110 and 70, so I just stick with that. That was my example for my vertical angles. It was my example for my corresponding angles. It's my example for supplementary angles. It's totally fine. If that's what comes to mind, you can keep repeating it. Just keep using it because you know it works. Okay, you don't have to come up with new numbers every single time. Work with what you know when you're showing those examples. Obtuse triangle, you had to have one angle that's obviously bigger than 90 degrees. You can label it, maybe 130 degrees. So then these two are going to be smaller. If I add them together, they're going to equal 180 degrees. So if you write your angle measurements in there, they have to equal 180 degrees. One is large, two are small. Madison.
On the test, are they gonna ask us these questions?
On the test, you're gonna have to draw some examples. You're gonna have to fill in missing angles. But yeah, you're definitely gonna have to draw examples. So you have to show that you know it, you understand it. Any other questions? Okay, if you are watching this at home, I hope you are well. Hope to see you soon. Please see me if you have questions. Go ahead, Ava.